I'm going to bring you guys in here midstream. Let's see how much time do I got left. Okay, I got a little bit of time. I'm going to bring you guys in midstream on this repair. This is one of two on this repair. This is RO30. I've got this one plus another one that we're going to talk about. This is a Texas Star 1200. This amp's been completely apart. The guy that owns this is actually a fairly decent technician. He likes working on tube stuff. This is his own power wire modifications that was stolen directly from the BBI design. This is a solid copper bus. He's installed this. We're not going to worry about that. He bought this amp used. He says he's had all the pills out. He's checked all of them. He had to replace the primary 12 volt on and off relay, which it's working. What he says though is it's not making any power out the poop poop. And I'm like, okay, cool. So some of the solder work in here is a little questionable. We'll go back and we'll fix that, but it's nothing that I'm too overly alarmed with at this minute. So I'm kind of in a hurry of trying to get as much done as I possibly can. I got to go back. He's got another one, this OG Hurricane, which is a beautiful little amplifier. This thing here, we're going to look at this here in a minute. But for right now, where we're at and looking at things is we got to figure out if the RF's coming in or even going out, or if all these pills are popped, or what the deal is. So the transistors aren't lighting up. We got nothing coming out the poop chute over here. Let's make sure we're on 10 times reduction. Yeah, we're way down. So, no heat there. Ooh, okay. The combiner is getting a little warm. So, we got to ask ourselves, let's probe over here. Massive signal there. Probe here, massive signal there. Massive signal there, massive signal there. Okay, so going through. But I got nothing here. Nothing. So we got signal going in the transistors. We got signal coming out of the transistors. Either got a cancellation going on in the combiner. The combiner doesn't look like it's ever been taken apart though. Anyhow, gentlemen, welcome. We're continuing on in the RO repair section of life. Wonder if the tuning cap's gone bad. Let's see, 1, 2, 3, 4. That's not the right number of turns. 1, 2, 3. It should have like close to 6 or 7 turns on it. Massive signal. No signal. All right, I got to pull the combiner apart. Output tuning caps fried. So 100% of the RF, other than 0.009 of an ohm, is going directly to ground. Yeah, that would explain everything. Let me go get another 75 puff worth of capacitance. So we're shooting for 75. I got 78.4. Close enough. It beats 0.009 resistance to ground, right? how's that phrase go? Resistance below an ohm is futile. Yeah. Okay, let's slap this in. Let's see what it does. Amp off. Hello, 1 2 1 2. Amp on. Hello, 1 2 1 2. Turn on big power supply. Amp off. Let our voltage come up. Hello, 1 2. Amp back on. Hello, 1 2 1 2. Hello, 1 2. All right. Before we get too carried away here, it is working. How well is it working? We don't know. Combiner's a little warm. The combiner's okay. Output combiner's okay. Hello, 1 2. 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 All right. I'm gonna call the customer now. So, Texas Star, working. Let's call and tell the customer what I found and all the good news. That this is yet another very, very easy repair. Kind of like the one I worked on just a few videos ago where the wire just broke off the same cap. So this sucker was shorted out. All right, let's move on. All right, gents, let's have some fun now. This is the Hercules 2. There is a Hercules 1, and if I'm not mistaken, they made a Hercules that was white that had a remote face. This is a neat little amp. This is your amp control. Low, high, off. Short sideband delay, long sideband delay. Preamp low gain, preamp high gain. What makes this unique is this was in the 80s. This is straight out of the 80s technology, right? Here's our fan wires. They've been disconnected, okay? Let's crop this up just right. What makes this amp really cool is one, is forced air cooled, but two, this thing is a 1x4. So it's one 55 watt transistor, which was like a TRW 31 something or other. That has been blown. So let's go down in here and take a look at this. Focus, you bastard. There we go. Currently what's sitting in here is a 1446 transistor. And if we look here, you'll see that it's shorted. Somebody's blobbed a ton of solder on it. The other thing is that transistor's in there backwards. These are our 10 ohms to ground, or 15 ohms, or whatever they are. This is our hot lead for the power wire. That transistor's in there backwards. So we know this is bad. No question. Bad. This whole section, bad solder work. Bad solder work. So what I've done is up here in the fuse holder, I just took the fuse out. Now, according to the owner of this thing, it does not power up. These are four 60 to 80 watt TRW, what are these? PT8949s. The TRW company, I think, eventually got absorbed by Motorola, but they made really, really cool transistors. They were in the forefront of transistor development for quite some time. But eventually they got sucked up by, well, Motorola. If any of these pills are popped, we would replace all four of these with the MR455HG or the 2879, or pardon me, 2290. This would not be a good candidate for us to do a 2879 conversion. Too much heat, not enough fan. So the guy said don't spend a ton of time on this. He's not wanting to dump a bunch of money into this deal. He says it does not power up. Fair enough. We don't know if it's been hooked up backwards. We don't know. We don't know. All we know for sure that this driver transistor is in backwards. The rest of this is all stock wiring. This is all stock. At the end of the day, I'm grateful that the guy sent it up here because I went and I looked at my YouTube videos. I don't have another one of these anywhere in my inventory other than in my head. I must have worked on one of these for somebody at some point, at some time or another, way back when, and I just don't remember doing a video or what it was labeled as. So we'll make sure to tag it in the description portion of this for tags so it can be found in the future. But this is the Hercules 2. These things were bad in their day, dude. This would have run straight neck and neck competition with the 67 in its day. Smaller footprint, roughly the same amount of power consumption, 4 transistors at 25 amps apiece, still 25 amps. So, I don't know. All the positive voltage goes through these diodes, except for the driver section. These diodes. It's got a giant, or not through them, but by it. And we're going to know right away if it was ever hooked up backwards. If it was hooked up backwards, I'm not going to spend a lot of time on this. But I did want to get in here and take a quick look at it. That's a good sign. Quick look at it to document. Okay, so we're just charging an electrolytic. Let's go ahead and put power to it, and let's watch what happens. Everything we do gives us a little bit of a key on what's going to happen next. So if I hook up this positive lead, and there's any kind of little bit of spark, a little bit of a spark, but I'm not seeing any current load over here on the ampere meter. So let's see, power on, nothing. Okay. Preamp, which normally runs independent, nothing. So one of these traces in here that comes from the positive side of the circuit is probably blown. I would venture a guess. And it might be just as a cold solder joint up here. There's a junction that's right here at the front of the amp. It could be down underneath this capacitor. Let's go ahead and remove this capacitor, this little filter capacitor, and let's take a look underneath it, and I also want to check the value of the cap. Okay, so sitting here probing around, I got 12 volt positive all over the place, but I've got no ground reference. So let's zoom in here for a second. And directly underneath our capacitor is this little trace right here. That trace is our ground reference for this whole interface on the front. Okay? Whole thing. This is our positive reference. It's our ground trace. I couldn't help but notice, I couldn't help but notice, if we follow from this trace here, and then we follow it around, it ends up coming out on this pin here. Well, that pin there, we follow it along, and it goes directly over here to the remote. There is no fused link between the remote plug and the front of this amplifier. So if it's going to short, it'll pop this link. Now, do I dare take a piece of wire and replace, jump over this trace? Because it might just pop another trace down the line if there's something still open. But everything on this faceplate tells me there is no remote reference. None. I mean, and no ground reference at all. So I'm going to try jumping over that trace. We'll see if it hooks up, turns on, or what it does. We'll see. This is not the situation where more is better. This is the situation where we want to use something small and somewhat sacrificial. All right, so we used a little tiny piece of wire. Let's go ahead and hook up our ground. Everything is off. Amp on. Amp on. Oh. All right, not happy with that. Everything else is working. Okay. Let's see what we just let the smoke out of. So the two traces we just watched burn are part of the same circuit, and it's for the sideband delay, short or long. And as I'm looking around, I can't help but notice this glob of solder. It is completely shorting out underneath the board, and where that comes from is our input coax. So our input comes from here, over here. It goes through this attenuator to our splitter for our input signal. Something attached to this trace here. Let's see here. I need a point utensil. This will work. All right. Let it focus. 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 You fuck. Focus. This trace here, and these two pins inside this switch are jumpered. They're attached like this inside the switch, and they rock back and forth. The armature goes click, 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 click. This trace runs down, goes to here, and it disappears underneath the board. Where does it come out? Don't know. I caught this when I flipped the amp up on its side. I did a visual sweep between the board and the heatsink down this side, like this. Ooh, oh yeah, nothing's hanging out. I don't see anything down in here. It's going to cause a short. I didn't catch that short until we were on the other side. But that has to do with this coax. I've got to take the board off because I think that this is going to be relatively a simple fix. The driver transistor's got to get fixed. This whole mess has got to get fixed. No problem. I've got that technology. I have that knowledge. No problem. We've got the amp powering up now. We understand what caused the problem. We're powered up, and at some point or other, somebody flipped the sideband delay switch, and that's got a short attached to it, and that backed up, and it burned this trace up. But it burned it up behind this, so we couldn't see it. Well, you guys just watched in living color me smoke the traces off the board on this thing. So let's go find our short, and to do that, to really chase that down. Now there has been some other kind of Funkamide modifications go on here in the back end, and I don't know if I can find it, but I did sneak another ball of solder out of this that was fairly significant. A little bit half the size of like a BB. It was back here. So, I'm gonna go ahead. I'm calling it for the night. It's 9 o'clock. I'm done. I'm not being out here till midnight. I'm just not doing it. It's been a busy day. Day started at friggin' 6:30 this morning. I didn't go to bed till like 2 last night. I'm calling it. Tomorrow, I'll come out here and I'll pull all of these Allen screws out, and we're gonna take the board off, and we're gonna figure out where this goes from here. Because this looks like a 6-pin relay to me. We're going to figure out where it attaches over here. If there's a short over here, then we got to figure out the other thing that I noticed, because I was looking at the front side, you guys are looking at the back side. The duration light stays on. just on all the time. We'll figure this out. I think we're close. Till tomorrow. Okay, so let me slide you guys over. Let's go, we'll start here. I'm gonna do the best I can to keep all this in frame. Okie doke. Let's frame this like that. Yep, that'll work. If we take this trace that I evaporated on camera and we look at it here, after we pulled this board up, we found that this trace attaches to this trace. Anyhow, it's direct cross on the other side. There's a pass-through via that goes here and a pass-through via that pops up here. Where that pops out is over here, at the back of the board here. So then, that in turn goes to this trace here, okay? This trace here, in turn, goes to this resistor. This resistor, make sure I got this in frame. So we go from here to here, okay? And that pops out here. So that trace, make sure I am kind of blocking you guys. That trace there pops out here at this resistor. Well, from here to here, this resistor ties here to here, but it pops out, goes to this trace. Now it goes to this transistor. Well, we've got this added resistor that's here. You guys see this here? Well, this goes from the center leg of this transistor through this diode back to this trace. And this transistor is blown wide open. I mean, wide open. Let's orientate this differently so this makes a little bit more sense. So down in here is this diode, this load diode here. Okay. This transistor has been bypassed by this diode for some other reason. Don't know why. So it's taking the center of this transistor and coupling it back to positive. There is a positive rail that comes from the on-off switch that goes directly to the far leg on this transistor, this leg here. And then in turn, this is the ground from the front that controls the sideband delay. This transistor is blown wide open. So, the million-dollar question is, do I unsolder this transistor here, which is, let's face it, the solder work on those, am I too close, or you're not being able to figure out where to focus camera or what the shit. So we can see the solder work here is just impeccable. How far down the rabbit hole does this guy want to go on fixing this? Does he want me to order this transistor for him? I mean, obviously we're going to have to repair the traces up here. This transistor being popped completely open is what caused our traces over here to smoke. It's like I said in the previous segment before it let the fries out, I'm going to replace this and it's just going to back up to the next circuit and show me the next weakest link. And I thought it was from the remote. So this wire here plugs into the remote pad over here. And I thought somebody popped it from the remote. We'll come to find out that control circuit here is blown wide open. So what we could do is pull the transistor out, repair the traces, and then we can go on and make the amplifier work. And then we can figure out if it's even worth salvaging or not. The determining factor is going to be the cost of these TRW transistors. And even at that, somebody else, they might want to invest the money into it. This guy got this amplifier in on trade and wanted to see what I could do with it. He didn't want to spend a bunch of time and money on it. So if it's a fairly simple, easy fix, you guys follow? All right, I'm going to pull this transistor out. And then I want to repair this trace over here. That one and its partner that decided to let the pubes out. We're going to do it differently than this quick hack. We're going to fix this well. Do this differently here, this one here. Anywho, I'm going to put power on it and see what pops next. Hopefully nothing. And then we can bolt the whole thing up and we'll go from there. This is somebody else's modification here. This is an afterthought. And if you look down in there, you can see somebody's already tried to pull this transistor out once. It doesn't look too hot. That looks pretty skogy to me. All right. Okay. Of course, this is disabled now. So preamp's working, at least indicated and all that kind of stuff. And on, off, so on, high and low is working. This is disconnected, so let's, I want to pull power off on this before I decide to short myself out, either between this cabinet and some other mystery trace on the amplifier. Okay. That is the primary reason we ripped the whole thing apart, is this trace right there. So there's like no flux in any of the solder. Man. I have to spend 20 or 30 minutes just reflowing solder joints here, for frickin' sake. There we go. Okay, back to this thing over here. As we can see, there are no pass-through traces. Like, these traces on the bottom side do not hook up to anything. Let me, okay, that's good. And these, all three of these, four of these joints down here look pretty scody to me. At least on the top side. So why I'm here, instead of soldering them from the top and then having something flow back. Man, working on this camera sucks. Let's go ahead and rework these while we're down here. Solder that. Where it sucks it through. Good. Suck it through. Good. Suck it through. Good. Suck it through. Bloop, bloop. Come on, burp. Burpee. all of this for something I might not even end up getting to fix. Okay, I want to put the heatsink on it now. Well, let's bring this little portion of the saga to conclusion. I just spent countless, I don't know how many hours, like 4 or 5 hours dicking with this thing. This circuit here, I can tell you right now that the switch was in that position, it was in that position, and the preamp was in the off position when whoever had this hooked it up backwards. And then they went in, they tried to dick with the key or the driver circuit. There is the transistor I pulled out of there was an NPN, this guy. It's an NPN. And what it needed in that position was a positive, negative, positive. And it needed it with the base collector emitter setup to properly drive this LED. All that was to make this LED work, and the keying circuit was blown wide open. So we had 12 volts getting dumped directly back to the ground feed that controls the whole face of this thing. It does power up. The preamp does work now. The output transistors, these TRWs, I ended up bypassing the driver section, and I had to manually fire because it's the way this amp works is there's a transistor that controls the actual key up function, and that in turn drives another transistor, which would be this little guy that I just threw down on the table I had to find. Drives this little guy, which in turn was driving the primary relay. Well, once I figured out all I had to do is short 2 of the legs together to get the main relay to open and close, I just bypassed everything because I was sinking a lot of time into this. And for me to thoroughly repair this, I'd have to take the board off yet again, which is like a 25 or 30 minute procedure. Pull 2 transistors that are in the back of this amp, one of which had already been replaced at some point or another. Replace those 2 transistors and make sure that they were right, and then figure out the circuitry around them that drives them. Then reassemble the whole thing yet again, because I can't key it without having heatsink attached, and because the way the board's laid out, there's 3 different spots with ground that are common, but then you need cabinet. I jumpered over the transistor, fired the relay after I bypassed the driver's section, and we got nothing. They're dead. The transistors are dead in them TRWs. So I just reached out to the owner. I haven't heard back from him. That's okay. I've got to move on. So I went ahead, I put this back together the way I got it. And if he wants to do anything more with it, which I doubt he will, we've got probably 4 or 5 other deals going on right now between me and him. This guy that owns this is a hustler. He ended up buying this out of an estate. And I think honestly, he sent it up here to hope that I could quickly do a turn and burn on it real fast, and also be able to show everybody a Hercules 2. This is a neat little box, and I'd love to find one that somebody wanted to. I mean, he's going to be in this thing for the labor and time. Right now, I'm willing to walk and simply write off all my time and my energy in it, right? But for me to completely repair this and put it back to full working order, it's not worth the amount of money that's going to need to go into it. So cool little design, cool little fan, different kind of style of face. I like how it's textured up to us. But this is the closest we're going to get to a Hercules 2 amplifier for now, but I'm sure there'll be another one that shows up here eventually. Okay, let's switch modes and let's go back to the main reason that we're all here today. RO number 30. So, cleaned it all up, did all the power wires to it, modded up a couple stuff, resoldered a bunch of stuff in here that I didn't like how it looked, like resoldered around all the transistors, secured the relay down. This is a solid copper bar, yo, attached to a piece of Lexan. That is never coming off. So we went ahead and we went through it top to bottom. He says he doesn't want to do coax connectors yet. So be it. The only thing I got to do is hook it up, show it running. And we also did the fan upgrade on this as well. So let me get my 150 amp Anderson clip out. We'll We'll plug it over here on the workbench. And let's get this song and dance over with. It's time to move on. Okay, amplifier off. We're in the 1X scale, and we're running 14.9 or 15.0 volts. So we're going to see this thing fluctuate. The reason we do that is because after we make it through the connections of the workbench, through the too small connector onto the amp, we're usually at about 14.5, which is real world operating voltage. We're going to put about 120 watts worth of peak drive in it. Hello, audio. So we're burying it off the scale. And we're going to go up to 2X. And as you guys all know, when I put the multiplier on, that means when the needle goes all the way here to the right, that's 2,000 watts. Big hash mark between the 40 and 60 is 1,000. Each large hash mark after that's another 200 watts. So, right about 1250 with 120 watts worth of drive. Audio, 75 amps on AM. So we'll go over to sideband. Audio. 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 1,000 on sideband, 1,200 on the PEP meter. It's running just like a Swiss watch. Sorry, this is the first time I run on sideband. I'm looking at everything. Audio. Run it right to the corner. 900 to 1,000 watts on the average meter. 1,200 watts peak. So, needless to say, let's see. Let's turn this off. Pass-through tune is perfect, so you won't have any receive issues. 1 1 1 1 1 1 1 1 1 1. Hello, hello, hello. Okay. And our input tune is hello 1 1 1 1 1 1 1 1 1 1 1. Beautiful. 2 bars, 2/10 of 1 watt worth of refleg. This is done. Now, if you guys can't hear it in my voice, I'm getting a little burned out. I've banged out 30 amplifiers in 10 days, 11 days. Halfway, about halfway. I took on 86 repairs. And then, yeah. Needless to say, the next thing that you see come from here, well, no, I can't even say that. I'm not going to even make that statement. Gentlemen, I'm just going to say thank you for tuning in and following along. We got a bunch of fun stuff coming up. I can't even explain all of it to you right now, but there's going to be a lot of really cool shit. Go down. Big shout out to my Patreons. This gentleman here is a Patreon. Actually, the last 4 or 5 videos that I've put out are all Patreon supporters. I love them guys. I'm grateful for that. I can't, you know, it personally offends me when I listen to other YouTubers like, hey, you want to come support my channel, blah, fuck off. There's a reason I thank these guys at the end of every single video, because I honestly am grateful and am thankful for them and what they do for all of you guys. You just sat here for almost an hour with no ads on your phone, on the toilet. Think about that. When was the last time you got to watch a YouTube video, anything? Right? Right. Okay. Big shout out and big thanks to Penta, Siglent, Bird, MacMan, XS, Coaxial Dynamics, the Tooth Fairy, the Virgin Mary, our Lord Holy Savior,